So, good morning. 3, 2, 1. Houston, we don't have a problem. So we can start. Thank you so much for coming. Yesterday at the opening, we heard that the future starts today. I'm really happy that I can say when mentioning space and Slovenia, future started already yesterday or even a day before. Because you all know that our Baron Yuri Vega was immortalized by two things being named after him in the space because of his contribution to the physics, mathematics, astronomy. But also, even more, we are proud of Nordung Potočnik, Captain Potočnik, who was one of the pioneers. And everyone who never been to Vitanje, either international visitors or Slovenes, I really think you should go there. The center of Nordung is one that really inspires us because the space. But it's not only the past that connects us with the space and exploration. Today you will see that we have excellent companies, scientists, and of course guests that will connect us to that. But probably all Slovenes know, I don't know that if international visitors know, that we also have 4 astronauts of Slovene descent who did the spacewalk and who did exploration. Ron Šiga, Jerry Lineker, Sunita Williams, and Randy Bresnik. And one of the best surprises probably today is that there is a man in this room that did the spacewalk, that spent 149 days in space, and that is Randy Bresnik. Randy, I know this is not an official visit, and they will not tell that you're here, but just one thing. Being up in the space, looking down, you also gave everyone the picture of the speakers, the picture of Bled. How was it possible to spot Bled from the space?
When we're flying overhead on the International Space Station, we are at 400 kilometers altitude, but we're moving at 25,000 kilometers per hour, or sorry, per minute. And so, you know, that's about 10 kilometers every second. And so Bled goes by very quickly. So we have to be able to see, you know, the Baltic and then find Ljubljana and then be able to go, okay, just northwest of that is Bled. And so I was fortunate to have a nice clear day like today to be able to get the picture that Rebecca gave out to our guests. And so it was nice to be able to have be of Slovene descent and be able to see Slovenia from orbit and be able to then share that with all of you.
Thank you. And Randy, thank you for inspiring us all the time. Cannot even imagine how it is to look at it from above. But I think that one man here knows how it is to look at Slovenia from within, and that is Minister Zdravko Počivalšek, who is keen on space exploration and who understands that it's really important that Slovenia is part of ESA and that we stay connected with the top science and top business explorations as well. So, Minister Počivalšek, it's my great honor and pleasure to invite you to stage, please.
Dear ladies and gentlemen, dear Ms. Ajša Vodnik, I'm honored to be able to join this distinguished audience. Space is one of the hottest topics at the moment. It represents a new business opportunity for big companies and for micro, small, and medium-sized companies with innovative solutions. Big advantage of space is that almost all sectors be included, from agriculture to artificial intelligence and all in between. Space technologies can play a significant role in accelerating economic growth or green and digital transition. We have recognized space technologies as a strategic area for Slovenia as well. We can already see some really impressive projects being conducted in Slovenia. They were in fact recognized by European Space Agency and other big players. We have financed 48 projects in total value of almost 12 million euros in past 5 years. We became associated member of ESA in 2016. Slovenian companies are engaging in various fields of space industry, with a special focus on niche products and services. We understand that good cooperation between companies and academia with government support is crucial for effective use of space potentials. This is why we work closely with more than 40 Slovenian companies and research institutions. I'm thrilled that the number of new stakeholders interested in space is growing rapidly. Slovenia became an associated member of the European Space Agency, as I said, in 2016. Association agreement was upgraded last year, adding some new possibilities for cooperation. One of them is a tender solely for Slovenian companies. Slovenia actively participates in the areas of Earth observation, general technologies, products, and human and robotic exploration. We are also considering options to join some additional programs next year, and I'm really happy to see Slovenia on the map of space economies. In September 2020, our country joined Space Nations, and we have sent 2 satellites into space, NEMO HD and TrainSat. Both of them are technological demonstrators in the field of Earth observation. Investments in space industry are definitely profitable. I will not mention Slovenian company by its name because the numbers speak for themselves. Due to previous project with the European Space Agency in value of only 650,000 euros, this company has received almost 9 million euros for projects on global markets. This was definitely money well spent. Therefore, we have established a special intergovernmental group for better coordination of space activities. In June this year, we have signed a letter of intent with the Italian Space Agency. We have applied for a membership in the United Nations Committee on the Peaceful Use of Outer Space. We hope that the committee will approve our application this week. October 2021 will be another milestone for us. So-called human centrifuge will be transferred to the Nordic Center Planica. Slovenia will become one of the 3 ESA member states able to carry out bed rest studies. Space is also one of our priorities during Slovenian presidency of the EU Council. In July, we organized a conference on space traffic management with more than 90 participants. Its outcome will set a foundation for EU's further actions. Our ministry focuses also on preparation of national space law, drafting national space strategy, And we are also organizing a joint conference with ESA Space for Green and Digital Transition at the end of September in Ljubljana, and a business delegation to Expo Dubai during Space Week in October. Our aim is to establish close cooperation not only with ESA, but also with old and new space powers. I'm proud to say that some of Slovenian companies are among the world leaders in their niche areas, and I'm convinced that new ones will follow. It's nice to see that the representatives of ESA and NASA are sharing the floor with Slovenian companies and academia today. Your discussion will surely cover a lot of current issues related to our common topic. Moreover, I hope some of good experiences will encourage other Slovenian stakeholders to follow their lead. Thank you, and a lot of success in today's work. Thank you.
Thank you so much, Minister. Thank you. I know that you'll have to excuse yourself, but we appreciate that you have a passion for that and understanding, of course. And now it's my great pleasure to also introduce you the panel that we have today from NASA, from the United States, Johnson Space Center. With us is Rebecca Bresnik, an expert in law and a woman who really is key to connecting, not only in space, but on Earth, because this is important. Gordon Campbell, he's coming from ESA and is in charge for enterprise and climate change. Mrs. Andreja Gomboc, who is our scientist, and it's really an expert in black holes, which is something that we'll discuss a bit, because probably we are all super interested, but don't understand much. She's coming from Univerza Primorska. Mr. Nova Gorica, I'm sorry. Mr. Rotovnik, SkyLabs, the company that really did a big success by launching 2 satellites just recently, and with that we'll explore more about that. And Mr. Olaj, who is the CEO of Duol, and exploration and the knowledge you get from that, doing things for space also probably are really important for Earth. But no further ado, my first question will go to Mrs. Gomboc. So we said exploration, black holes, all the things that probably us who just read a bit about space don't even understand. But what do we get here on Earth by the exploration that you scientists are doing?
It's a question, universe, how it began, what is it composed of, what are stars? It is something that people were wondering many thousands of years ago. Now we live in an era where we can actually really study this with physics, laws, with instruments. We learn about our place in the universe. So we were always wondering what is the Earth in the center, or how it is. So now we can view on this question from a different perspective, because we are discovering planets around other stars lately. So this is a completely new era, and we are also finally at the stage that we can ask questions and we can study scientifically questions like, are we alone in the universe, or does life exist somewhere else in our solar system or in other solar systems? So what do we do by studying that here on Earth? Of course, we can learn about how to treat our planet with global changes and everything. And there are many, many practical things that we gain from developing technology needed for space explorations on Earth with ground-based telescopes and on satellites. For example, black holes that you mentioned, we can use the same equations of Einstein's general theory of relativity that describe the motion of black holes, material in the vicinity, how it falls in the black hole, and so on. The same equations we need if we want to describe exactly the motion of, for example, global navigation satellite systems like Galileo system. So without the knowledge of these equations, we would not be able to use the system because it would be wrong for 12 kilometers per day. So, and there are many other things like the methods and techniques that we develop in analyzing data in astronomy, for example, astronomical images or data in radio astronomy can be used then in, I don't know, for example, in the medical diagnostic, it helps in communications like Wi-Fi. There are, for example, things that we can learn from studying pulsars. Pulsating stars can help us detect, for example, a human being under some debris after earthquakes. So there are many
practical aspects.
Yes.
What was the turning point that was it technology, and what was the really turning point that people could reach that perspectives that you can be so precise? What was that, and what is, for now, you would say, the hottest thing that is happening in the exploration of the universe and space?
Yeah, I think the development of basic science and technology, they always go hand in hand. Especially in astronomy, we can see that. There are always some daring questions, exciting challenges, and then we use the resources, human resources, technical resources, and then push the boundary also on technological level a bit further. And then this goes, of course, this enables development of technology, then enables us to study better, maybe more distant parts of the universe, or more accurately derive something. So currently, I would say there are many really exciting topics. For example, one are definitely gravitational wave events and projects like LISA that has been developed by European Space Agency. Then there is the James Webb Space Telescope developed by NASA. There are also ground-based projects like Vera Rubin Observatory and the survey, which will really scan the whole sky to deep distances, magnitudes in just a few nights. So there are many
things,
projects.
Really exciting things. Mr. Campbell, ESA is there really, and with that, Europe also wants to be an important player in exploration and also understanding how this can benefit also us on Earth and the economies around European countries. Do you think that ESA started soon enough, or there are other nations who are in front of us? How do you see the position of ESA right now?
Okay, good morning. That's a very interesting question. I think, I mean, European entities in general, and Slovenian entities in particular, are at the leading edge of developments in space-based capabilities and also the capabilities to use space infrastructure and space data on Earth as well. If you look at the start is always the sort of the inspiration, the science, etc. That's always going to be the initial driver, and I think again Europe and Slovenia is amongst the leading exponents of both the research and the transition of that research into other technologies, as was been saying, like leading edge medical imaging and other more Earth-oriented applications. If you look at entities such as the Organization for Economic Cooperation and Development, they have a whole agenda for saying, look, this starts as something inspirational and scientific and institutional, but eventually it will transition to something commercial. And I think we're seeing that to a large extent really in Europe. It started a couple of years ago, maybe a couple of years earlier in the US than it did in Europe due to things like differences in availability of venture capital, etc. But a lot of the main people in the US side of things are actually Europeans. I would point that out. And I think, I mean, European companies in particular, a lot of the startup companies that we're seeing coming through now, in particular in Slovenia, are taking developments in information technology, in sensors, in all of these different technologies, and really putting these together to drive forward the commercial exploitation of these capabilities, and also being fundamental elements of enabling the expansion of space as well. Some of the critical technologies that you have to have on satellites and space hardware, like how do you manage where the spacecraft's pointing, how do you manage the propulsion, how do you protect against radiation or protect against thermal stress going from super bright sunshine to very dark areas. All of the technologies involved in that, they're to a certain extent banal when you're developing the Earth, but they're absolutely critical for the effective functioning of space technologies in a commercial setting. And again, Europe is very much at the forefront of a lot of these capabilities and turning them into commercial revenue.
And I definitely don't want to put it in a way that we're just competing, because I'm aware that we are collaborating, and with that, Ms. Bresnik, you are really the one who believes in collaboration, but not only believes in that, but you're also drafting an important documents that we can collaborate, because whenever we think about space, probably people are inspired, but things will have to be regulated. And how, in this front, things are developing?
So maybe to look at the past a little bit, the past 15, 18 years, I've had the privilege of being the attorney for the International Space Station, and I look at the International Space Station cooperation as just being a phenomenal model of international cooperation. On the ISS, we cooperate with the European Space Agency, the Japanese, the Canadian Space Agency, as well as the Russians. And the interesting thing is when you see in the news, say that a good example, the United States and Russia were not getting along. I'll have 3 telecons that week with the Russians on whatever project it is and how we are still cooperating in space. So what I really love about space is it's still the one area I think that brings countries together still. Even we were cooperating with the Russians through the Cold War in the area of space. Cooperation in space too, I think, is very important. We're not going to be going into space by ourselves. It's expensive, and we need each other's money, the practical aspect, and we also need each other's technologies. Not all great ideas come from the United States, we know that. A lot of great ideas come from all over the world, and we need those ideas. The future of space cooperation, so recently, about a year or so ago, I concluded negotiations with partners for the new Gateway platform, and that is an international platform that will be outside of low Earth orbit, and it'll be orbiting the moon instead, and we'll be doing cooperation again with the European Space Agency, the Japanese, the Canadians will be also contributing their arm, as well as new space partners. And I think that also goes into, what does the future look like? It's not going to be just the partners that we've had on ISS. And when I say just the partners on ISS, I also should say, although the partners I mentioned are the main partners, we do cooperation up on ISS with approximately well over 100 other countries. It's just not, they are not main partners in the cooperation. I see that being the same for the Gateway, but bringing in the more non-traditional partners, bringing in commercial entities, not just US commercial entities, but international commercial entities. And then from Gateway, what are we doing on the lunar surface? Again, bringing in more non-traditional partners. And the question, though, when you talk about the framework, the legal framework, we've also recently drafted the Artemis Accords. And the Artemis Accords is a new framework on how will we cooperate on the moon. So while we have treaties that talk about cooperation, the Outer Space Treaty as well as 3 other treaties, those treaties, particularly the Outer Space Treaty, is a bit general. And so what we've done in the Artemis Accords is we've gotten a little more specific about, what are the important things that countries are looking for with regards to building on the lunar surface. A very important thing is interoperability. You want international standards. So when we go to the moon, we can plug and play with one another on the surface. So interoperability with each other's modules is very important. You want to set up safety zones. You want everybody to be able to go up there, set up a zone for the activity that they're doing without that zone being encroached upon, but you want to do that also in a way where you're working with one another. Also the idea of ownership, you want to be able to, everyone agree that we can extract and we can use these resources. You know, it would be amazing to figure out a way to use regolith to build items on the lunar surface. If you could use regolith to build something with a 3D printer, I mean, that actually is being looked at right now. So again, that framework of, and we have currently 11, almost 12 signatories to the Artemis Accords. But again, that I think is the future of a framework of how we're going to cooperate. And the Artemis Accords is not necessarily a legally binding document, but it's a framework of countries coming together and saying, this is how we'd like to cooperate. And we'll see if that turns into something more legally binding later on.
We'll come back to the ownership and all that, because probably this is something that we're all wondering who will have the first flag in and that, but let's see later. But I really want to turn now to companies, Slovene companies that we are proud of. Mr. Rotovnik, already mentioned by the minister, launching of the satellites, why it is that important, not only for your company, but also for Slovenian economy. Is this something that you would say it's an important turning point in Slovenian indulgence in the space?
Thank you for the invitation. Yeah, of course, I totally agree. I mean, 10 years ago, we didn't have any space industry in Slovenia. So actually, we are a quite young country with such technology that I said that today we have. And of course, when you start thinking about space technology, the first thing when you start thinking about that is to have a picture from space, taking it down to the Earth, looking for the Earth, or observing the stars, for example. But as economy, I mean, it's really important that first you gain all the knowledge that you need, that then you can start innovate. And at the same time, you need to find also the niche market. And as a representative of SkyLabs company, I must say that the SkyLabs actually find the niche market in space segment. And the space technology is actually quite highly added value technology at the end. And when you have such technology, then you start thinking what you want to do. And actually, you need to start building key competences if you are discussing about the space exploration. And those key, let's say, competences need to cope with many different challenges. For example, space is a harsh environment. There is radiation. So basic electronics that you can see today on the Earth, you can use it on the Earth, in the cars, in the televisions, mobile phones, will not work in space. So if you want to have some really reliable and robust development in space, you need something special. You need to first to be familiar with this technology, and then try to mitigate those effects that are present there. And when you gain this knowledge, then you can start, of course, building different, let's say, parts that are needed for the satellite platform. So we need, for example, power supply system. You need communication system, so to communicate with the satellite from the ground. You need onboard computers so that you can take any actions received from the ground, so that you can turn the satellite pointing to the Earth, taking the images, or taking the pictures or signals from outer space. And so you are then building different small subsystems. And at the end, when you put all things together, doing also a little bit more intelligence in the sense of fault-tolerant detection, isolation, and recovery policy, at the end you get quite an innovative platform. And this is something that SkyLabs today already have in its portfolio. And this is something that brings SkyLabs also on the map as a space company. And I must say that this also enables us, so these key competences from which we started, today enables us that we have really a huge number of commercial activities doing for really bigger and bigger companies.
Mr. Rotovnik, you sound that this is super easy, but we know that it's not. So there, NASA and all the other big, not even companies, but they're supported by the governments and everything. And there is a startup that thinks, oh, we want to do something for space. But I know that you came out from the university in Maribor. So how does this really work? Because how could you do this satellite launching and probably there was not a flow of capital from, let's say, our state or something. So how was this done?
Yeah, this was the, I think, quite hard part for us, quite hard learning stage for us, because doing space technologies is not cheap, and you need to start somewhere. And what we do is to gain some knowledge, to start building these key technologies. And also, I think there was some really lucky moment also for us, because that time, European Space Agency, 10 years ago, was visiting Slovenia. At that time, also Slovenia checks the possibility to participate in ESA programs as a member state. And they come over the Maribor to the university for the visit. And they were also in the laboratory of Mr. Professor Isto Kramberger. And they saw some pretty nice things there that were already developing there for the ground segment, let's say. And actually they gave us advice. You need to start competing also in this space race. And this was the beginning for the SkyLabs company. So actually, at that time, the scientists, the students, the postdoctoral students there apply for one project with ESA. And this opens then the doors to start doing in this segment. Actually, what happened is the fact that this first project, where this team was participating, was led by one really famous company from UK, which actually put the first satellite as a beacon for the Galileo constellation. And actually, this company at that time already knows that they will be sold to much bigger players. And we have opportunity to be there, our team to be there at that time, and they really disclose some really interesting secrets about building space electronics, etc., etc. And this was the faster process for us to gain such knowledge and to start, let's say, building and also to find the niche market in this segment. And this was for us let's say, the starting point. But of course, when you're limited with the budget, and you want to build a satellite, you go with the smallest possible one. So this was the reason that we started with the nanoscale satellite. This is the budget that we have at that time, the financing that we could get. But we didn't go with the bottom-up approach, so we start with the CubeSats, just use some regular electronics from the ground segment, put it into the satellite. But actually, we learned a lot in previous years, and actually miniaturized the technology that is today used in much larger, much bigger, much high-end satellites into this smaller one. So in this platform that we currently today have, it's also, we can state that it's the same, we can prove the same reliability as much high-end platforms.
And Mr. Olaj, the question for you is, you have an established company in Slovenia, and then you decide, I want to do something for space. How does it really happen?
Oh, I didn't decide by myself. They choose me because of our experience. I was listening now, all my colleagues, and where we are now. You know, we are at the moment at the Mars with our habitat. We have the lowest possible volume, the lowest possible weight of the goods to cover as much as possible surface. And what we are doing now, I'm, you know, legal aspects. What does it mean, force majeure, delivery of the goods, legality? So, you know, we are already facing with the things at the moment with the NASA. We are partner not only of NASA, we are partner, grateful to ESA, NASA, Roscosmos, Japanese, Canadian, Nanjing University in China. We are partner of them. Because of our experience, what we have at the moment with our domes in the ground, we are ready to solve the problem in the space. It's quite, you know, for me, simplicity, it's the most complicated thing in the world. Believe me, so that's very simple.
How your engineers are doing it? You know, everyone, we have Mr. Bresnik here, everyone is like, wow, going to space, and we see big companies and entrepreneurs now really going there and experiencing and be really inspired by all that. But then you have engineers here in Slovenia, on planet Earth, and you need to imagine how it will be. So what are the courses? How do you do it? And of course, what you learn out of it.
But it's a very simple task. There is no difference. There is absolutely no difference between the Mars. You know, I'm sometimes when, you know, I was laying in the grass looking into the moon. Where is the moon? Somewhere upstairs and so on. But in the end, like exploration of the Wild West, America, it's the same story. You just take as much you can take with you, and you go something new. And you're looking for this.
Is it really that easy, Mrs. Gomboc? Because, you know, we were discussing Captain Potočnik Nordung and his views, and it was in the beginning of the last century, and he was absolute visionary. And now when we see that there can be habitation of the space universe, we still probably don't believe really. But where are we? How simple it is?
I think it's not so simple. It's a short answer. So yeah, definitely space, like Mr. Rotovnik was saying, it is a harsh environment already for the equipment, for satellites, because you are out of the Earth's protection zone, atmosphere. If you go further out of Earth's magnetic field, it's even worse. So sending humans to space environment, it's much, much worse than sending, much more demanding than sending instruments. So I think going to Mars is a really big challenge, because Mars is several months of travel away from Earth, and so far we've only sent people to the moon, and moon is quite close by, much closer. It's only 1 light second away from Earth.
That's quick. But why they picked Mars? I was always wondering, why not Moon? Because, as you said, it's easier. Probably radiations are different, I would imagine, but please explain that better. But why we are talking about Mars and not Moon?
Well, we are talking also about Moon. So Moon is like the first step, and then from the Moon we would like to go to Mars. I guess Mars is a capture, so it's a planet, so it's larger. It's in some ways similar to the Earth. In some ways it's not, because it doesn't really have an atmosphere, or very rare atmosphere, and doesn't have a magnetic field. But I think Mars is also close by, let's say, in these terms of solar system. And Venus is too hot, Mercury is also too hot, and other planets are giant gas planets. So Mars seems a reasonable option, but it's still a difficult and challenging one.
Maybe if we go back to ESA and the views we hear about exploration and why it matters that companies and, of course, the scientists are connected. We don't hear that much to really fly people there, or you will do it through the collaboration with other agencies. So do you perceive ESA more on the ground of really exploration, scientific knowledge, and of course then also use for the companies? Or you also want to be part of habilitation of, let's say, other planets?
I mean, our fundamental mandate is we're an industrial policy agency. We exist to support member states develop their space industrial capabilities. So, I mean, we would be looking at both aspects of that by pushing the initial boundaries on the scientific side of things, first of all, and as has been said before, that generates a number of fundamental hardware and other developments as well. I mean, the volumes of data we're generating, for example, has really been pushing a lot of the AI developments that we've seen over the last few years as well. So there's all that interaction that's happening as well. I think the important message I think was coming before was the fundamental element. there's going to be collaboration, okay? And that collaboration, the context of that collaboration, that's what opens up the opportunities for companies that may not see themselves as space companies. You know, there's a lot, as I was saying before, there's a lot of components that have to be integrated together in a coherent way. And there's no one company or no one country that has all of the technologies and all of the capabilities, both to manufacture these elements and to connect them together in the way that needs to be done. So the collaboration is absolutely essential overall, and the collaboration creates the opportunity for niche companies developing elements that, like I say, may not originally think of themselves as doing something that is fundamentally space-oriented, but with a bit of development to be sustainable in harsh environments, or to work remotely when we've got a time lag in communication, whatever. Just, you know, building on the initial capability that a company like that has by adding these sorts of elements opens up the commercial possibilities of exploration and other sort of human space domains.
We also see big tech companies and, let's say, their leaders as Elon Musk, Bezos, Branson, that are sort of want to be there, want to be first. And there's a big question. On the one hand, people are saying, wow, they are inspirers. They're the ones who are really opening up the universe in space. And the others say, oh, why don't they do something on Earth? Why they go there? And we know that this divide will always be there. But maybe, Ms. Bresnik, how do you see them? Are they important for really gaining, again, traction for understanding universe? Is this good? Are they the pop stars of the universe?
No, my husband is. What I love about what we're seeing now with commercial space, with Musk, with Branson, is it's opening up space to people like you and I. It's not just the government astronauts. I think previously we all thought that the only people that went into space were government astronauts, and that was never a possibility for the rest of the population. So looking at, you know, the Branson flight, I think what that does for us and for our children, they realize, wow, I could probably go to space too. You know, the issue is obviously transportation to space is extremely expensive. These flights are extremely expensive. But if we could get those costs down, is it possible for a family or for an individual to be able to go into space together? Is that possible? And I think what's important about that as well is when your kids see that and they understand that possibility, they start thinking more about occupations in STEM, science, math, technology, and then their brains, you know, the one amazing thing, so I teach a space law course, the original thinkers, the really great thinkers of space, not all of them were scientists. Some of them were writers, they were school teachers, and it was thinking through just the possibility of, wow, you know, to be able to go to space. But to do that, I think there has to be in their mind that there is that possibility. And that's what I love about what's going on right now. The other thing I think that is very unique too about now and what's going on, I'm working on the side as a pro bono legal work for a company or an organization that's opening up zero-G flights to people with disabilities. How many people with disabilities ever thought that they would be going into space? Well, in October, we're going to be flying 10 people with disabilities into zero-G. And then from there, hopefully, we'll be able to do parabolic flights for these individuals. And the European Space Agency, even ahead of the United States, they are actually selecting their first disabled astronaut in the next astronaut class. And if you think about it, you know, do you need your legs in space to get around? You know, are legs needed? So again, I think space is being opened up to more than just the government astronaut. While they're important and they have their place, I need to say that.
Especially in your family, but okay.
But again...
No, it's great. And I want to turn to you, Mr. Rotovnik, by opening up the space. Of course, we know for now it is really just for the selected few ones, right? But space, basically, also with your satellites, open to smaller companies because you can compete. And do you think that now that technology, in a way, is cheaper, that will mean more competition and different ways how you can do it? And of course, the aspect of the protecting your knowledge, so intellectual property of that, how your company is dealing with it?
Yeah, the competition is already there, of course. A couple of years ago, already started with this fast-track commercialization process. But it's quite interesting, at the moment where we are living, so we witnessing 2 months ago or 1 month ago for two private entities have first commercial space travel. I think this is the era that we are coming now in regards to the space technology. I think we are this is the start for the space human exploration in more frequent way. But to do that, of course, we need to still develop technology that will need to be even more robust, because we are now talking about even more seriously about humans, because there will be much more flights in the future, and the probabilities is on that matter really important. And I think that the first thing what will happen is that we will testing this technology not only in the LEVO, but also, as was already today mentioned by Ms. Bresnik, in Gateway, so in the platforms which will be stationed around the moon. Also, we'll be witnessing probably the first landings, landings on the moon with the probes, with the rovers, and also with the habitats. I think this is the most efficient, cheaper, faster way to do that, to get to the most closest object near the Earth. I think this is the way to go. And to do that, probably, and if we really want to do this technology really fast, to really commercialize that sector, a lot of new technologies still need to be developed. And I think starting with these small satellites to test these new technologies is the best way to do.
And Mr. Olaj, your field of expertise will be hugely important if people will want to stay up, let's say, the moon and so on. What would be your guess or a prediction? How long will it take that it will be possible?
There's a question not for 1 million, but for probably $1 milliard of the dollar. When, first of all, probably it's necessary to build up the deep space station, and from there probably to fly between the Earth and the Mars. Generally, I'm not concerned. I mean, to answer on this question, generally it's not important. What is the most important thing at the moment? It is that this Mars exploration and investment, this is the trigger. This is the trigger of the economy. This is the trigger. This is our future generally. Because everything what we are, sometimes people think we didn't solve the problem on the Earth and now we are thinking about the Mars. It's not true. This is our push for the future. And the space technology, it's nowadays the most important thing to make our life tomorrow, after tomorrow, better and lighter. And also, you know, I have a bookkeeper in my company. We have in Duol, we have two companies. One is money making. The second one is money spending. I'm money spending because of the space.
Lucky you.
Generally, others are making money, what I'm then spending. At the moment, it is like it is, yes. But as I told you, we need to think about, we need to be focused on, because sooner or later, Mars, it will be destination.
Mrs. Gomboc, sooner or later, what does this mean in the timeline of Will we see people living there, or our kids or grandkids or grand-grandkids? Where do we stand with that?
I don't dare to make such predictions, or it is difficult to say. But what I would like to point out maybe is that Mars is definitely a good destination, but we should never think that we will all move to Mars when we mess up things on the Earth, because there is no planet B. It's on the Earth that we need to solve also our problems. So I think I also like seeing these new space travelers, private companies doing that. What I'm worried a little bit about is how sustainable that is. If suddenly millions of people will want to fly up at the top of the atmosphere, how this is going to affect the climate changes on Earth.
Mr. Campbell, you are also in charge within ESA for the climate change. And of course, this question of sustainability of exploration and all that, but on the other side, the knowledge that you get out of that, how would you measure this ratio?
Yeah, there's clearly trade-offs. I think. I mean, the fundamental problem in terms of understanding the Earth system processes is really some of the interactions. We really don't have a proper characterization of them. We understand the basics, but some of the for example, what gets called tipping points, for example, at what point does the amount of fresh water coming off glaciers in Greenland switch off the North Atlantic drift that then cools Western Europe? We don't know what that switching point is, because there's one parameter pointing one way, one the other way, and we don't know how that interaction happened. The only way to have that information properly characterized is very large volumes and very long time series of data. So we need the data, and really the only source of these sorts of data sets is satellite Earth observation, combined with other data as well. But really, to give the long time series and the overall picture, you need the Earth observation. So putting something in space, yes, it has environmental impacts. So I mean, rocket launches create a lot of pollution. There's a lot of other contamination and things that happen as well. But I think the impact of really having a proper characterization of these fundamental unknowns at present really is absolutely massive as well. So for the time being, I think we do need to go with these sorts of capabilities, because the amount of uncertainty is so vast that unless we get some sort of hold on that, we're still in a difficult point in terms of the economic aspects of climate policy. How do we make decisions on what countries should be doing about stopping using coal, stopping using diesel cars, or things that are really going to make impacts on their economic development? How can we ask that if we're really not sufficiently sure of the climate processes that this is affecting?
And then is probably the different aspect, also the debris that we are sending, and I'll also ask Mr. Rotovnik about that, but and we don't maybe even worry that much, or do we, about the space debris?
That's an increasing worry, and I think NASA, ESA, a number of space agencies, a number of companies as well. Again, I mean, this comes back to what's the role of institutions and private companies. There's a lot of private sector thinking and innovative thinking coming along, and how can we actually clean up a lot of the debris that's there? Because there's a lot, and it's getting worse. I mean, the satellites we have, for each satellite, we've got about 2 or 3 situations per week where we have to decide whether we're doing maneuvers to avoid debris and things, because they're all in a lot of the same orbit areas. So it's quite a management task, and we're actively looking at how we can clean some of these debris up, and we're working with innovative companies for ways of doing that. And at a certain point, it can be a commercial market in itself, and the role of the agencies and the governments is then the governance and ensuring everything works, not actually doing it yourself at taxpayers' expense. And I mean, another point as well on minimizing debris is, I mean, anybody, or us in particular, but in theory, everybody, if you put something in space, you're now obliged that you should be able to deorbit that safely, rather than leave it in space as debris or junk or whatever. That's part of, so enforcing that regulation, oh, it's not a regulation, that requirement on companies or other organizations putting anything in space is a fundamental element of minimizing space debris as well.
So here definitely, Mr. Bresnik, is an important question of a legal framework or really practical things like ownership, like really being required to bring back things that you're sending up. So how does this work? And cannot even imagine, you know, like how many people are on that, who is taking the lead? Can you discuss it with Chinese, with Russians, with ESA, NASA, everyone? So, and of course, there is no enforcement to do it, because even if you do something, who will be aware of that? So, I don't know how you structure that as thing called legal framework for space.
So it's, I think, a legal framework for space. It is difficult, you know, with, you know, very good point of what was just made. Debris mitigation is a huge issue, and we do not have a legal framework. We have guidelines, but I think most countries are very interested in enforcing those guidelines. I know we at NASA, we enforce those guidelines. We were actually the originators of guidelines for mitigating space debris. With regards to ownership, though, so we do have the Outer Space Treaty of 1967 that talked about ownership, and that specific treaty stated that no country could take national appropriation of a celestial body. So basically, no country can come in and claim that they own the land of the moon or a planet. The difficulty is, though, during those negotiations, although it was discussed at that point in time, there was nothing put in the treaty with regards to private ownership of any resources extracted from planets or the lunar surface. So that was left somewhat ambiguous. And actually, one of the major reasons that was never addressed is at that point in time, the Russians did not want to start promoting commercial activities within space. They saw it more as a state-owned activity, whereas the United States at that point in time did realize that there would probably be commercial activities, and they wanted to address that. But as I said, it was the agreement was made on consensus, and to get everybody to agree, sometimes we don't put all the details into our agreements that we would like to. So with that fact being left out, and with that not being addressed, we're now 50, 60 years later, and we are doing those commercial activities. And there are differing opinions on whether or not you can extract resources and own them. The United States passed a law in 2015 that does allow private ownership. The UAE, Japan, Luxembourg are some other countries that have also passed similar rights within their legislation that does allow ownership. But if we talk about all these, these great commercial activities in outer space, but how are you going to get companies to want to put their money into doing these activities unless they know when they go to space that they are going to get some return on their money? I don't think every company is going to have one part making money, the other part spending money for the company's whole life.
Dušan, no, you're okay with that, huh?
So again, passing that law really allowed U.S. companies to say, okay, I'm going to really start investing on these technologies to do these types of activities. And I think that is important if we are truly looking to go back and partake in these commercial activities. Like I said, not every country agrees. There is the Moon Treaty as well. The Outer Space Treaty was signed by well over 130 signatories, whereas the Moon Treaty, a lot less. The U.S. is not a signatory to the Moon Treaty, but the Moon Treaty talks about ownership in the sense of, in their Article 11, they want to set up an international forum, an international organization, or use a current international organization that would then parse out those resources once they're brought back to the Earth. And again, I don't know how many companies would be willing to invest if you're telling them anything you go up and bring back, you may not reap those benefits. I think the other important thing too is as we're talking about doing activities in space themselves, actors that are going up there, as I mentioned, 3D printing, they want to know that if they extract regolith and use it for 3D printing, that they can then own that end product. So again, very important. Can we use that regolith to build structures in outer space? We're not going to be, the cost of bringing stuff into space is expensive. We can find a way to use the resources up in space to build our structures in space. That would be phenomenal and would also help with the economics of space.
So how your company, SkyLabs, is working around that, working for ownership, intellectual property and all that?
Actually, I think for space, when you're putting something into orbit, you don't need to be patented because it could be hard to disclose it. Yeah? But I will try to come back to the previous point when we talk about Earth sustainability. As already mentioned, Ms. Professor Gomboc, there is no B option for our population on Earth. And I think, or I also believe that space technologies will have an important role in the future for building this Earth sustainability, especially the fact that population is increasing. We don't know where is the limit, but it's not important at the moment. So the population is increasing. We need to establish the 100% recycling cycle. Zero emissions if we want to remain in the situation that we have at the moment. And this is probably hard to achieve quite soon. I believe that with new technologies, this will be possible in the future, of course. But other thing, when the population is increasing, you will also need more resources. And if you want more resources, you need to get there. And probably this is where also the space technologies come closer. And also another thing, when we are talking about these resources, we are also producing a lot of waste. And increasing the population, there will be more waste, something that could not be, at the end, recycled, perhaps. And also, again, probably space technologies could come closer in this direction. So I think the space technologies are the key driver also for this future topic, let's say.
Great, and when you're discussing, I hear a lot of collaboration, really drivers for development, and we also want to tackle security and trust. And with that, I would like to turn to Uroš Majcen, who is the co-chair of AmCham Ready for the Future committee, but also our partner today, S&T. Thank you so much for partnering with us, and is in charge for the security. So, Uroš, your views on space and why it matters for Earth, please.
Thank you very much. I hope you can all hear me okay. I have a brief presentation to discuss because I want to jog a little bit of memory for you about it and display because it's still morning and it's 1 hour in the room. So I'll go briefly through and just keep a food for thought as regards to trust. When we go into the venture into the unknown as the space is, and when we talk about the first pioneers in space, and we talked about Hermann, Potočnik, Nordung, and other ones. Let's see if this actually works. Yes, we have the building the foundation of trust. At first, when you talk about Hermann used his brain, paper, and pencil to correctly calculate whatever is needed for orbital flights, orbital maneuvering. When we talk about, that was a bit too fast. How can I go back that way? Yes.
You see, technology.
It's a challenge. Let me hide this now. So we talk about two remarkable women, Katherine Johnson and Dorothy Vaughan, who were called like a human computer. What does it mean? They used, or the astronauts relied on their calculations so that the trajectories would be correct. So it means the trust. The information they provided were accurate, so they are concentrated on what they were doing. And they used computers as a Siemens, very old computers, were like a backup. They were not the ones that we rely on. They were used as the ones as to support their calculations. They were remarkable at that time, and it was like a start of, as I say, as we move to the computer technology, as we use less from the human perspective and more to the machine part. Now, when we've moved further over the time, let me see if this works. When we talk about computers they use, and so I use some of the things, let's say for the first moon landing, and somebody say use the trick here, because the former has bits, the other one has bytes. Like all of you have now mobile phones in your hands or in your pockets. Those are at least 100,000 times more powerful than the computers they use. And the question we should ask at this time is, why is this so? So, I mean, it's very difficult to see at the bottom, I'm very sorry. It is because what these devices were designed for is to just deliver what they were intended to. Keep it simple. We heard today a number of times, keep it simple. Keep it simple is something that we often do not, or we forget to use when we apply technologies from, let's say, such a use into the commercial use, when we overcomplicate, when we overexpand, when we make things bloated, and then they are not as much reliable as they were before. And that's the key. So these are machines, as some of you, maybe the last ones remember, this is the 386, this was one of the first PCs, processors that used in the PCs. In the International Space Station, it still exists. The question is why? Because it does the job. Perfect, it does the job. So it provides the information that is secure, so the astronauts, and I'm hoping that Mr. Bresnik will correct me, that the information are reliable, secure, and I'm happy that I can do this, and I'm not bothered with what's happening here. Like, when you apply this to the modern world, how many times are you, let's say, disappointed where, my mobile phone is not working, information is not correct, look, this application, it works terrible, it consumes too much memory, it crashes. This is something that you cannot ever use in space. Because, number one, you have more and more information that you use, and the information needs to be reliable, and needs to be secure. So if we move forward in this, what we need to do is build the entire foundation of trust, so that the people have trust that exploration in space will reap the benefits for all of us. The technology that we use is secure, and then when we apply this to the modern world as we see right now, things are, and these are key points, they're similar, but not quite the same, because the challenges are so much magnified in space, as we discussed. Once we leave the protective coat of Earth, we have the radiation, which affects the computers massively. When private entities are building these technologies, they need to know that this, and the users need to know these are secure, that they will be working, they will be operational all the time. And here comes a very important problem, which is when you combine not the governmental entities, international agencies, but also private entities, that the whole supply chain in this is reliable, also means that what they provide is reliable and secure. Critical aspect is, whatever you do, whatever many sensors you have, you apply, and we discussed that we don't yet even know about our Earth, how it is, and how the information we have, we don't have all the information. What is critical is information that we have, and they're provided by this technology, must never be lost. A single byte lost can mean a catastrophe in space. We cannot just reboot the machine. We cannot just go and install the update or bring another one when something is 100 million kilometers away. We have seen a number of cases where we had cases with the failing, for example, the Hubble telescope, we tried to bring it back. Or the rover, does it work, it doesn't work, how big a challenge is this? But if we do this... Let me
test something.
Yeah.
If I step a bit further, what it means? That time.
Yeah, I know, I'm seeing it, it's over there. I have only one more slide. So we rely on the technology more and more. We kind of like stop thinking and put the thinking to the machines. But machines are reliable as we build them. And if we think that they need to be trusted, they need to be secured. You don't see it very good here on the black slide, but it says a couple of things that we see in the commercial life are the same things that will affect the space exploration. The same things will affect the technology. And let's not forget it. If we say it's secure, we have a small step in building the trust. If it is trusted, we'll have a support of the public and the general population when we venture into the unknown. Thank you.
Thank you so much, Uroš. It's always a blast to have you. Thank you so much. And with that, of course, we came to the last question. I tried to have some predictions, and you said, oh, that's a 1 billion question, and so on. But anyway, I would love to hear from you who are in the area and experts in this field, the future of exploration, the future of habitation. What do you think, and why universe and space inspires you? So maybe if we can start with you, Mr. Olaj.
Okay, thank you. No, as I mentioned already, for us, space is just a trigger, because everything what is okay for the space, it's okay for the world, for the ground. So our biggest challenge and trigger in our company it is that we are working with absolutely new materials, with absolutely new technologies not existing in the world. They're off the records. I'm talking about, at the moment, photovoltaic films. I'm talking about nano-coatings, photovoltaic nano-coatings, which is the future of technology, dreaming about. But this is what is giving to us this, the biggest advantage what we have at the moment. So it doesn't matter what is the cost. Thanks to ESA for all the support and the open tenders for the money, but in the end, we are investing, as also my colleague, Mr. Rotovnik, will confirm, that we are generally investing our money into this technology, just to be in front.
Great, thank you. Mr. Rotovnik, how do you see it?
Yeah, so the close future, I think it's already known. So building these gateways around the moon, also the new space stations probably will arrive around the Earth, etc., etc. But at the moment, there still exists no technology on the world that will prevent electronics from start doing wrong things in space. So there is, at the moment, no technology in the world that will actually will be running out of the box. So you still need to have some mitigation techniques implemented. And this is probably the field, if we will succeed to develop such products that could sustain in harsh environment, in a radiation-enriched environment for 100 years, I think this would be another major breakthrough.
Mrs. Gomboc?
I will speak more about the space and the science of, that I'm dealing with. So, yes, I think there will be great new things coming, new findings coming out from several really exciting projects. For example, like two that I will mention that at our University of Nova Gorica we are involved in. So this is Cherenkov telescope array for detection of high energy radiation, cosmic particles coming from the universe. And then the other one is Vera Rubin Observatory, which will address many exciting questions. For example, two biggest questions that I would like to see answered in my lifetime, which are, let's say, open and also disturbing not just for astronomy, but the whole physics, are dark matter and dark energy. So currently, all that we know about the universe, it consists of stars, planets, galaxies, and so on. And this represents only 5% of the universe. There are 95% of the mass or energy in the universe that we have no idea what they are. They are called, part of it, it's called dark matter and part dark energy. And I think this is really a crucial question for physics and for all other parts of science. So this is where I would like to see some answers in the next decades.
I'm certain you will give some contribution to that, but I need to have an additional question with you. We heard the question, are we alone? And we are asking all the time, probably, since we are born and then that. So are we alone on
I don't know. I think we are finding that there is a huge number of exoplanets just in our galaxy, and I think also similarly in other galaxies. So there are billions and billions of exoplanets. Some of them are similar to Earth. Now what we don't know is, this is where astrophysics can answer. But then it is the astrobiology part which tells us if there are right conditions to develop, and there are huge unknowns in this area so far.
So black energy, black matter, for me this is even more important question.
Yes.
So thank you so much. Mr. Campbell, so the future, what it brings?
I mean, the priorities, I think, for ourselves is how do we use space capabilities such as Earth observation really to engage the combination of governments and industry for addressing the climate change issue, sustainability, but also the economic growth aspect as well. You can't ask a large part of the world, you guys stay poor so that the rest of the world's okay for the rest of us. We need a sort of more of a democratization of how things are developed, and also the access to the information as well. I mean, I think what's happening increasingly, in particular as a result of some of the developments we've talked about, there's much more democratization of the access to satellite data now as well. NGOs can have a look and see what mining companies are doing in Africa or Central Asia, whatever that was just unthinkable 10 years ago. So that sort of opening up the space capabilities to non-experts and just the mass market is really part of the way forward. In terms of your underlying drive, in terms of the exploration, I think we should look at where we've got to already. I mean, all of the conversations up to now, we take the space station as something for granted. Yeah, we've done that. It's boring. I mean, like one of the things I always found shocking or surprising was the ESA astronauts on the space station. They're part of the ESA telephone network. If they want to phone our PR guys, it's just like somebody in another office phoning us up. You take it for granted, but it's absolutely, we're already at an advanced stage. And I think what's happening in a lot of the technologies, Earth observation, space science, etc., is, and hopefully it goes the same way, we go step by step, is we get to a certain point with the technologies. Industry realizes how they can build these capabilities in a more efficient or more effective way. Also, with these technologies, the scientists realize we've developed something to do a certain thing. We can also do all these other interesting things with it as well that we never thought of at the time. That's what we've been doing with the space station in terms of how we use microgravity and the issues of manned space flight and how we can use it as testing for other things. The next step would be doing similar sorts of things on the moon, but an order of magnitude more surprising. So I think we have to accept that's the fundamental element of the process. It's move forward, bring industry with you to understand how the whole thing can be commercialized and done on a not just an exclusively institutional basis, and also realize all of the other cool things that you can do while you're there, and then step by step, space station, Mars, space station, Moon, Mars.
Yeah. But thank you really also to say, let's celebrate what we already achieved, because we do forget that often. So, Ms. Bresnik, the final thought goes to you, future, what it brings.
So just to add on to what was just said, if you think about it, we've had somebody in space for the past 21 years continuously on the International Space Station, and that really is amazing. I will say there is one thing wrong with the telephones, however. You can't call up, they can only call down.
They just never answer.
Maybe that's on purpose. So for my thoughts of the future, I think low Earth orbit is no longer going to be governed purely by governments. Low Earth orbit, I think, is going to be taken over more and more by commercial entities. And they're going to push on the hard stuff onto the government. So that is going back to the moon and going to Mars. Going back to the moon, the US which is also, they'll be doing it in collaboration, obviously, with all their international partners. Their Artemis program is to go back to the moon, but not just go back to the moon, touch down, stay a couple days and go back. It's to go back to the moon to stay, to have a sustainable presence on the moon, to build structures on the moon, learn more about what's there, learn how to live in a different environment. Yes, we've learned how to live in low Earth orbit, but we haven't learned how to live beyond low Earth orbit. And you don't go from low Earth orbit to Mars. You know, really the moon is the next step, and having a sustainable presence, looking at what energy resources are there. So it's not just looking at moving forward and what we want to do, but what will we find on the lunar surface that we can then take and bring it back to the Earth? Benefits. Are there any resources on the lunar surface, like helium-3? Solar panels. Can you set up solar panels where you can then redirect that energy back down to the Earth? What other energy resources are there where it would change our lives down here on Earth? So that was a really good point earlier. It's not just moving forward and not caring about what's going on still on Earth. It's to benefit our lives here on Earth. But then I think the important thing too is to explore beyond. Is there a way to set up launches and having an energy resource that we're not doing launches on Earth, which also you use up a lot more fuel. There are pollution issues with regards to launches as well. Can we do something from the lunar surface to where it's a completely different type of launch? It's shorter, it's more efficient to then go to Mars. And I think being on the lunar surface for the next whatever decades that will be, will then teach us how can we live beyond being on the moon surface. So very similar to your thoughts. ISS, now we're going to the moon, we're going to figure out how to live there and then go beyond.
Thank you so much. I think that the panel really deserves a round of applause. Thank you. We do live in exciting times. I don't want to push with the question when will be the tourists in the space, but one thing I do know. Today you can explore the beautiful gem called Bled and enjoy being tourists here. But before that, listen to other interesting panels. Thank you so much for being with us.